Hello everyone, Chandrika Bijore this side, student of IIPS GABB MCA. Today I am here to explain my assignment of theory of computation under the guidance of Saligram Prajapat sir. So let's start. Consider the case of grammar that generates a subset of English. This subset of English is defined using a list of rules that describe how a valid sentence can be produced. We specified that a sentence is made up of noun phrase followed by an article phrase. A noun phrase is made up of an article followed by an adjective followed by a noun. A noun phrase is made up of an article followed by a noun. Here are some rules. From these rules, we can follow valid sentence using a series of replacements. Until no more rules can be used, for instance, we can follow the sequence of replacement. Here are some sentences which is noun phrase, verb phrase, article, adjective, noun, verb phrase, article, adjective, noun, verb, adverb, the adjective, noun, verb, adverb, the large noun, verb, adverb. As these are as follow. Also, we can see that the quickly eats programmer is not a valid sentence. Refer to the grammar with the star symbol sentence set of terminals. The sleepy, happy tortoise passes, runs quickly, slowly. Set of non-terminals. Noun phrase, transitive verb phrase, intransitive verb phrase, article, adjective, noun, verb, adverb, and productions. Sentence. Noun phrase, transitive verb phrase, noun phrase, sentence, noun phrase, intransitive verb phrase, noun phrase, article, adjective, noun. These are as follow. And now we have question 1, which is use the set of production to show that each of these sentence is valid sentence. The first one is the happy or runs sentence, noun phrase, intransitive verb phrase, article, adjective, noun, intransitive verb phrase, article, adjective, noun, intransitive verb. After these three steps, the happy or runs. The second one is the sleepy tortoise runs quickly sentence, noun phrase, intransitive verb phrase, article, adjective, noun, intransitive verb phrase, article, adjective, noun, intransitive verb. After these four steps, the sleepy tortoise runs quickly. And the third one is the tortoise passes the sentence, noun phrase, transitive verb phrase, noun phrase, article, noun, transitive verb phrase, noun phrase, article, noun, transitive verb, noun phrase, article, noun, transitive verb, article, noun. After this four step, the tortoise passes the fourth one is the sleepy head passes the happy tortoise sentence, noun phrase, in noun phrase, transitive verb phrase, noun phrase, article, adjective, noun, transitive verb phrase, noun phrase, article, adjective, noun, transitive verb, noun phrase, article, adjective, noun, transitive verb, article, adjective, noun. After these six steps, the sleepy passes the tortoise, happy tortoise. Now we have second question, which is construct a derivation tree for the sentence in Q. The sleepy tortoise runs. Sentence has two parts, which is noun phrase and intransitive verb phrase. The noun phrase has three parts, which is article, adjective, noun, and intransitive verb phrase has one part which is intransitive verb. The article has the adjective has happy, noun has have, intransitive have runs. The question number third is, which is construct a phrase structure grammar that generates all the signed decimal number consisting of a sign either plus or negative integer and a decimal fraction that is either the empty string or a decimal point followed by a positive integer with an initial zeros integer are allowed. The code is as follow. The tortoise passes the sentence has three parts, which is noun phrase, intransitive verb phrase, or noun phrase. The noun phrase has two parts, which is article and noun, and the intransitive verb has one part, which is intransitive verb, and the noun phrase has two parts, which is article and noun. The article has the, noun has tortoise, intransitive verb has passes, article has the, noun has hair. The sleepy tortoise runs quickly. The sentence has two parts, which is noun phrase, intransitive verb phrase. The noun phrase has three parts, which is article, adjective, noun, and intransitive verb phrase has two parts, which is intransitive verb and adverb. The article has the, adjective has sleepy, noun has tortoise, intransitive has runs, and adverb has quickly. Positive integer non-zero digit integer, positive integer non-zero digit I is equals to 1 2 3 4 5 6 7 and 9. Give the package non for from of this grammar as followed. So here we have signed integer, which has a sign and integer and digit is 1, and the integer has a digit and and digit is 0, and integer digit is 9. And now we have signed decimal integer, which have sign integer and positive, and integer has integer and digit, and the positive integer positive has non-digit 0, which is 4. Now give a production rule in package null form for a An identifier if it can consist of one or more lowercase letters, at least three but no more six lowercase letter, one to six uppercase and lowercase letter beginning with an uppercase letter. If lowercase letter followed by a digit or an underscore followed by three or four alphanumeric character. These solutions are as followed. Now, several expressions to make us know from are commonly used to define phrase structure grammar. In one such expression, a question mark indicate that the symbol or group of symbol inside parentheses is optional, and asterisk indicate that the symbol to its left can appear zero or more times. A plus indicate that the symbol to its left can appear one or more times. These extensions are part of extended Baker's norm form. B, E, B, and F and symbol question mark asterisk and plus are called meta characters. In E, B, and F, the brackets are used to denote non-terminal are usually not shown. Now the question number 4, which is give production rule in Baker's not form that generate all identifier in the C programming language. It can identifier start with a letter and underscore parenthesis that is followed by one or more lowercase letters, underscore letters, and uppercase letter and digits. The code is as followed. Now the question number 5, which is give production rules in extended Baker's norm form that generate all the decimal numerical consisting of an optional sign, which is no a non-negative integer and one xy minus z asterisk expression term factor mul factor expression factor mul operator term add operator factor mul operator, and these are as followed. And the fourth one is expression term factor mul operator factor expression mul operator factor term mul operator factor mul operator factor expression mul operator factor term add operator mul operator, and these are as followed. And fifth one is expression term factor mul operator factor expression mul operator factor term add mul operator factor add operator mul operator identifier add operator mul operator. Now the question number 8, which is use Baker's norm form to describe the syntax of expression in infix notation, where the set of operators are identifier in the same as the B and F for postfix expression, but the parentheses must sounded expression being used as factors. For each of these strings, determine whether it is generated by the grammar. For infix expression, by it is not. If it is find the step used to generate the string, the first one is x plus y plus z not generated, and the second one is a divided by b plus c divided by d. Expression term add operator term factor mul operator factor add operator factor mul operator factor, or identifier mul operator identifier add operator identifier mul operator identifier. And the third one, which is m asterisk under parenthesis and plus p expression term factor mul operator factor mul operator expression factor mul operator term add operator term, and factor mul operator factor add operator factor identifier mul operator identifier add operator identifier. And the fourth one is m minus n plus p minus q, which is not generated. And the fifth one is m plus n asterisk p minus q expression term factor mul operator factor expression mul operator expression term add the operator term mul operator term add operator and term factor add operator factor mul operator factor add operator identifier add operator identifier mul operator identifier add operator identifier. Now the question number 9, which is our internal question. So the question is construct fa to accept the set of all string over 0 and 1 ending with 0 1 0. We have some points which is q0 q1 q2 and q3 and q4. Now the question number 10, which is construct a PDA to accept the set L of string over 0 and 1 ending with 0 1 0. A PDA is defined as followed. And here we have applied some rules and solved this question. Now we have question number 11th, which is construct FA to accept the set of all string over 0 and 1 ending with 0 1 0. Now here also we have some points, which is q0, q1, q2, q3, q4 and q5. Now the question number 12. Construct a TM that accept the language 0 1 asterisk plus 1 0 asterisk. Now we have some points, which is q0, q1, q2, q3, q4, q5 and q6, and we have solved this question. Now the question number 13, which is construct a PDA equivalent to the following CFG. Now the question is state q equal initial state, and q1 is state for handling 0 productions, q2 is state for handling 1 production, and q3 is state for handling the second 0 in the string, and q4 is for accepting state. Testing the string 0 1 104 initial configuration q0 0 1 0 4 z. Apply transition rule based on the input string q0 0 1 1 0, and these are as followed. The string 0 1 0 4 is accepted by the PDA. Transaction rules. Here are some transaction rules, which is as followed. Thank you for listening.